glad to be joined by Karen and Giant Sharma as well to give a summary of the spatial activity from Oracle Database World at Oracle CloudWorld 2023. So the focus that we'll have here is just to describe, I think maybe most interesting, are the couple of use cases, industry use cases that were delivered in sessions and new features that you're seeing in 23C, and really summarize what our activity was in terms of sessions, hands-on labs, and demos. And the purpose here, I think, is sort of twofold. Obviously, to make people aware of what went on with Spatial at CloudWorld, Database World at CloudWorld, announcements, new stuff, and also just to give you a sense of the degree of activity that we have with the spatial team at these events. So, hopefully it would encourage folks to try to come when they can, because there's some cool spatial stuff that you'll get to check out, as well as the whole rest of the Oracle ecosystem. The replays of previous Spatial Ask Tom sessions are available, so you can always go back, and we've got this bit.ly link, so you can check out recordings and see all kinds of other topics that we've done, and also see what the upcoming sessions are. And just in case there are a couple of folks that are new to Spatial, just taking about maybe 1 minute just to introduce what Spatial is. So Spatial has been part of the Oracle database for decades now, and it is just a mainstream data element within the Oracle database. We call it a converged database because the Oracle database manages all sorts of information, your traditional relational information, but also spatial, graph, native JSON data. We're part of that converged environment, and we allow you to relate and interrogate data based on location and location relationships, and do that all in the context of your business workflows. So Oracle Spatial allows you to store everything from the most basic sorts of spatial data, points, lines, polygons, and ask location and location relationship questions of that data. Beyond the basic point, lines, and polygon types, there are a number of other sort of forms of spatial data and ways of working with spatial data that Oracle Spatial supports, including 3D, geospatial imagery, connected routable networks. So managing that data and allowing you to ask all the sorts of questions that relate to that type of data. A few more things like geofencing, where you're monitoring the movement of objects into and out of areas of interest. Linear referencing, where you're keeping track of where incidents, events, and activities are located along linear networks. Spatiotemporal analysis. So you go from your basic point, line, polygon sorts of data to all kinds of other ways of managing and working with spatial data, all within the Oracle database. So this allows you to ask questions about containment and measure spatial relationships, and filter and search for things spatially. For example, like which properties are inside a predicted flood area, but also perform hundreds of other sorts of operations that answer basically any sort of location relationship question you could conjure up. And because it's just a standard feature of the database, you're doing this all within the mainstream context of working with data. So it's not anything separate. You do this in conjunction with and integrated with all the other ways that you work with and interrogate your data. And finally, how is it that you work with Oracle Spatial? Well, you work with it either from a developer perspective through SQL, through Java, through Python. You develop applications with APEX. You develop REST APIs with Oracle REST Data Services. You work with our no-code self-service tool, Spatial Studio, but you also use virtually every commercial and open source tool and spatial platform in the industry, because they all support spatial. So it's really open, interoperable access to all the capabilities I just described. So that's your what is Oracle Spatial in a nutshell. So Database World at CloudWorld 2023. Oracle CloudWorld is vast and encompasses everything about Oracle, from the cloud infrastructure through the industry applications. And database is a huge part of that. And at CloudWorld, we sort of carve out our database world portion. And so that's sort of where we sit within Spatial. And I want to summarize now what all went on with Spatial at Database World at CloudWorld. I'm breaking this up into three areas. Set of sessions that we delivered. They're sort of so-called learning sessions and theater sessions, a couple of hands-on labs, and a series of demos. So you can sort of see what it is that I'm quickly gonna punch through here to give you a feel for what went on. And you'll see all the way down at the very bottom, the very last item, this 3D demo has a little gold star next to it because it was kind of the star of the show. And so there's a couple. I'll get to that last, and there's a couple of cool videos that I would encourage you to watch to get a feel for what that was. But I'll get to that in a few minutes when I get to the end of this. Okay, so I want to start with a couple of learning sessions that were really industry use cases, and there were sessions that we delivered with customers that are doing really interesting things, different things between the two of them, but really interesting things with Spatial. And the first was ITIS Corporation. So ITIS Corporation, they are a systems developer. They build and implement systems and deliver professional services focused on geospatial solutions, so incorporating location intelligence, and also with a strong focus in transportation safety. It's not all they do, but it's a major focus for them. So they work for a lot of state departments of transportation, for example, and they showcase their flagship offering, their flagship product, which is their safety portal. Their safety portal is in place at a bunch of state departments of transportation, and it's built on the Oracle stack. And fundamentally, and sort of centrally here, it's built on Oracle Spatial as the sort of spatial data management and analysis platform, and built through APEX to create their custom portal application. So what the safety portal is all about is it's a place to accumulate a Department of Transportation's crash data, and using the ITIS sort of system, understand what are the sort of factors that are predictive of crashes. They incorporate all kinds of information, sort of highly sort of multi-dimensional information, taken into account all kinds of factor, of course, location, but also aspects of information about the driver and the roadway conditions and the weather and all these different aspects that are part of crash reports, and they implement these predictive crash models. So what they do in conjunction with that is then perform predictive analysis to determine, based on different sorts of remediation. So we've got lots of crashes happening in a given location, and we think we know why, and there's different ways of addressing it, different sorts of remedial action. So based on their predictive models, they'll look at what will be the impact of different remediation options in terms of saving lives, and determine what's the best remedial option. They'll also then do predictive modeling, and you can sort of see the curves that are whose labels are too small for you to see, I'm sure, in the bottom. But the point of some of the analysis they do is to look at what will be, once they've got the sort of the optimal remedial activity for a given crash area where there's high levels of crashes, and they have to pick because there's limited funding. Where are you going to get the most bang for your buck? Which of these projects is going to result in the greatest amount of saving lives? So this is fundamentally all about geospatial data collection, all this crash data collection, and all the geospatial data that relates to the proximity and location factors that drive these crashes, and again the remedial aspect of them. So this is like a tremendous use case with really sort of intuitive and societal value around what they're doing. And I would encourage you to take a look at ITIS has a whole bunch of information about their safety portal, and you can see what they're doing. And again, it's all based on Spatial and APEX. Well, the next session that we had was in partnership with CN Railway, Canadian National. So Canadian National, it's obviously across Canada, but Canadian National also operates down a swath through the central United States as well. And in total, close to 20,000 route miles of rail network that CN operates. So it's extensive and poses for them some real sort of interesting and tricky challenges that they're using Oracle Spatial to address. So the use case that CN presented at Database World was really a logistics use case. And the use case had to do with what they refer to as dimensional loads. And that really just means loads, rail loads that are of sort of unusual and extreme dimensions that are going to be very tricky to figure out how to get through the rail network because of all the different sorts of constraints and potential obstructions that exist for a load that is sort of extra tall or extra wide or traverses across multiple cars and is going to sort of stick out from the edges of the cars as the cars go around curves, and all kinds of very tricky logistical considerations. So that dimensional load problem is what they've addressed using the Oracle Spatial platform, and in particular by creating a 3D digital twin of their rail network that encompasses, well, the rail network itself, but then all of the surrounding infrastructure, so that they can paint a very detailed picture of both sort of obvious obstructions and sort of the constraints that infrastructure presents. So they have, they're in the process of, and sort of close to completing, a full LiDAR scan across their network, from which they built 3D point clouds. And that's one of the key features of Oracle Spatial, is the ability to manage not just 2D, but 3D data and point clouds, and do all kinds of operations on that point cloud data, which is exactly what we see here. So an example of what they're doing, something that we can see on the right-hand side here. So they've got maybe a dimensional load, one of these extreme loads, like we can see up at the top, and that's going to have to get from point A to point B, and they'll figure out what the route would be. But then along that route, what obstructions may make that route impossible? So, for example, their sort of digital twin will include a LiDAR scan of like this trellis bridge that we see, and then from that LiDAR scan, they've developed a point cloud, and then they will build 2D profiles that slice perpendicular to the rail, which is sort of what the train would have to traverse through. And then they will build sort of a composite profile, which represents sort of taking that profile along the bridge and squishing it down to a flat surface, a flat sort of polygon that represents the sort of the extent of obstruction. And if you look at that picture in the sort of the middle on the right, number 5, that shape you see there, that opening, represents in total what is available to pass through. So that's sort of the composite profile or slice through that bridge. And then obviously, if you then take that and compare it to the profile of one of these dimensional loads, you're going to end up finding out, well, is this thing going to fit or not? So you can see this example on the bottom where the clearance, if you look at this composite 2D profile based on the LiDAR scan and the point clouds, and then the profile of the dimensional load, you can see on the right that it just barely fits, like to within inches. So CN will have all kinds of detailed understanding of how close is too close, and is this, is this an acceptable tolerance, and all that sort of stuff. And even beyond that, this is sort of almost a very simplified example of a much broader set of scenarios. So, for example, maybe this train is going around a curve at this point, and so the profile of this dimensional load will actually be rotated a little bit on an axis because the rails will not be flat going around a curve. Or there may be articulation where, as you're going around a curve, the dimensional load will sort of stick out more from the side of the train as the train is turning. And they've got all the math around all of those considerations to determine what is a viable path. So what they end up doing is, at the end of the day, it's really just a sort of a logistics optimization exercise to figure out how they can get from point A to point B, given all of this is one of thousands and thousands of obstructions, potential obstructions that will exist. And that's what they sort out. So this, I think, is another really great sort of industry use case around spatial, and in this case, 3D, and how it's put to use at CN. So the next session that we had at CloudWorld was actually just a session this was one of the, we call theater sessions. So it's just sort of out in the exhibition floor, and people can just walk right up. And the point here was to reinforce how straightforward it is and right at your fingertips to take advantage of location in conjunction with your autonomous database, and in this case, your autonomous data warehouse. So the point here was to make it clear how much is by virtue of you have an autonomous data warehouse, you have a whole bunch of stuff immediately at your fingertips to work with in terms of spatial. And the first one that we call out is the ability to do geocoding just at the SQL level, without any other tools or applications or APIs or anything. Because in Autonomous Data Warehouse, there is a native geocoding SQL function. There is actually what we call a live lab sprint showing you how that works. And a live lab sprint is live labs is our hands-on lab environment that I'll talk a little bit more about later. But within live labs are lots of labs, hands-on workshops that may be 30 minutes, an hour and a half, 2 hours. And then there's live lab sprints, which are really just jump in, jump out, learn one very specific thing. And it's a very sort of an atomic example of a how-to. And we have one of those for geocoding in autonomous database. So it's really important that everyone realize that geocoding is right at your fingertips in terms of a SQL statement if you're in autonomous data warehouse. Now, beyond that, when it comes to working with spatial, of course, there's all the SQL stuff that you can do, and we've talked a little bit about that. But then there's this Spatial Studio tool, which is our self-service no-code tool. So the other reason to make that point about what's at your fingertips with Autonomous Data Warehouse is that this Spatial Studio tool is on the Oracle Cloud Marketplace. And you can deploy it from the Cloud Marketplace using a wizard that will install and configure Spatial Studio and Autonomous Data Warehouse and get them all prepared and ready to go with all the configuration set. Of course, you can use the marketplace to install Spatial Studio only and then get it set up with your own database if that's your preferred path. However, in the context of Autonomous Data Warehouse, the ability to just go to the Oracle Cloud Marketplace, go through a wizard, and have Spatial Studio and Autonomous Data Warehouse set up, ready to go, and operational is super convenient. And so that was really the thrust of this theater session. And I would encourage you to do both this Spatial Studio Cloud Marketplace installation and absolutely check out the Geocoding Live Lab Sprint. And it'll take you about 2 or 3 minutes, and you'll see how powerful it is. So one of the other sessions that we had was what we called a digital session, which was basically a recording, and sort of an on-demand recording. And it was a session on what are the new features for spatial in 23C. This digital session, which will be, is not available publicly to replay yet, but will be. And I encourage you to check it out because it was done by Karen Patanj, who's our host today. And it's a great summary of the new spatial features. And it actually goes a little bit above and beyond that and talks about some other new things that are part of sort of the spatial set of tools. So I'd encourage you to check out the recording when it is released. But the upshot and the critical items around what's new for spatial in 23C are threefold. First of all, from the sort of the new user, casual user, and even the developer perspective, ease of use was sort of the first thing that we addressed. And it's our sort of the first step along what will be more steps towards ease of use. But that ease of use has to do with both the syntax that you use to do something like define a geometry, create a geometry, as well as the configuration of or the creation of a spatial index. So the simplified syntax is actually twofold as well. You see on the top right is an example of the simplified syntax to create a longitude-latitude point in 23C. So all you do is the only parameters that you supply are the coordinates. That's it. Other example of simplified syntax in 23C is whereas folks would typically see a geometry in the database defined with a couple of sort of numeric identifiers that represent the coordinate system and the type of geometry. Well, we've introduced these human readable constants now, so that when you create a geometry that's, say, not a point like this, a longitude latitude point, but maybe you're creating a geometry that's a line or a polygon or a different coordinate system, those identifiers are now these human readable constants. Is something that you could actually look at instead of having to explain to people, oh, that's the code that means two-dimensional line, and you'd have to go in the documentation to understand that. Well, that's now human readable. The other ease of use item is the simpler approach to creating a spatial index. It was previously the case before 23C that before creating a spatial index, you need to insert a row of spatial metadata, because the index creation will look at that metadata to make sure that the data conforms to what the metadata says. For example, the geometry type, the dimensionality, and so forth. Well, you had to do that first yourself, then create the index. Now you just create the index, and we will automatically introspect the data, create the spatial metadata for you, and the index will create. So it alleviates that. The next area of enhancement is something that we've already talked a little bit about, and that's around 3D. And three things in particular. First, in terms of 3D point clouds, the ability to do math between them and basically look at the difference between one point cloud and another point cloud for the obvious purpose of change detection. What's the difference between these sort of 3D representations? How much deforestation has occurred, or how much of this building is there now but was not there the last time there was this scan. Vertical cross sections, we looked at that in the CN example, where you've got a 3D point cloud and you want to develop a 2D profile of it for the kind of use case that we looked at previously. So that's a new feature, as is 3D mesh, where unlike a tin that represents a triangulation to represent a surface in 3D, there's limitations to that sort of representation, that sort of quasi 3D representation, and that's that it doesn't allow you to do things like model overhangs. And a 3D mesh, on the other hand, is a much richer, full, true 3D representation of an object like we see on the lower right. So that's all part of the 23C, Spatial and 23C, and those are all just spatial features. So if you look at the 23C documentation in the Spatial Developers Guide and look at what's new, you're going to see those things. So the other major area of enhancement in 23C is the introduction of a REST interface to Oracle Spatial GeoRaster. So that's a pretty big, broad statement, but that's really what it is. It's not a specific endpoint for a specific sort of category of operations. We have REST enabled Oracle Spatial GeoRaster. So that means sort of the full life cycle of what you do with geospatial imagery in Oracle, you can now accomplish programmatically through REST. Now, there's a lot to this, and we'll be doing, a bunch of examples and the blogs and all that sort of stuff. But what you can do today is in the 23C documentation. The REST information is in the book in the documentation called Spatial REST API. These other features I described up above are part of the Spatial Developers Guide. And it might be worth if I just very quickly show you what I'm talking about to be able to take a look at these. So if we look at the 23C documentation, and we're looking at all the books that are part of the 23C documentation, if we go down to Spatial, you'll see here the Spatial Developers Guide. And in the Spatial Developers Guide, there's that What's New section. And then if we cruise down here, we'll see Spatial REST API. And in here, you'll see all the information about that GeoRaster REST API. So that's where you can go to learn more about those new features. And again, we will be releasing the video from that digital session that Karen delivered as soon as possible. Okay, we also had a couple of hands-on labs, and this is the first of them. And the title of the lab was a little bit cryptic: When Where Matters, How to Be in Two Places at Once. And the hope was that that would sound sort of intriguing. I wonder what that's all about. Let me see. Really what the topic is using Spatial and Python to identify potentially fraudulent financial transactions, which sounds a little more dry, but that's really what it was about. So this was all about a persona of someone that is a sort of a Python developer working in a Python notebook, and you're doing spatiotemporal analysis to look at a bunch of debit transactions over time and at different locations, and then just try to identify any potential fraud or suspicious transactions, which we refer to as an anomaly. And what you do in this hands-on lab is that you load and configure all of these historical transactions over time, and then you work with a Python library that performs spatiotemporal clustering, which basically means you're looking for items that occur in close proximity of both space and time. They have to meet both of those criteria. So you do that work, and then what you do is you say there's a bunch of transactions that a individual person made within a clustered time and location, but it turns out right in the middle of that same time period that they were doing all regular, normal transactions, there's one or two transactions that are happening much too far away, right within that same narrow time frame. So that's sort of the simple explanation of what would be what would constitute an anomaly. But in this workshop, you go all the way through sort of from scratch, getting the data loaded, configured, doing this spatial temporal clustering, and then doing the proximity analysis within spatial, the proximity analysis to determine what is too far to be sort of normal. So this hands-on lab is publicly available to anyone on Live Labs now. So I would encourage you to check it out. It's Live Labs is, I've mentioned it before, and I think what I'll do is just, if I come to Live Labs, just to make sure everyone is familiar. Okay, developer.oracle.com Live Labs. So you can come to Live Labs, and this is across really the whole spectrum of Oracle technology. But within that, if you look for spatial, you'll see a bunch of spatial workshops. And one of them is the one that I'm talking about right now, Pinpoint Suspicious Financial Transactions with Oracle Spatial and Python. So this one you can do and yourself, and it's actually set up with what we call in Live Labs the green button. And what the green button means is that instead of running this workshop in your own cloud tenancy, whether it's your own free tier or your own paid tenancy for your company, this one runs on a Live Lab sandbox, which is spun up and provisioned and all set up for you to use for, I think, 4 hours, which is more than enough to do this. So I encourage you to do that. All you got to do is have a Oracle.com account. You can come in here, run this thing, and do exactly what I was just describing. So that was the Spatial Python hands-on lab. We also did a Spatial Studio hands-on workshop called Assess the Local Impact of Sea Level Rise, the Oracle Spatial Studio. And in this case, in this one, what you did was do that Oracle Cloud Marketplace installation of Spatial Studio to create an instance of Spatial Studio and an autonomous data warehouse instance, and just load a bunch of data, load and configure a bunch of data, predicted flooding based on sea level rise and cultural features like buildings and schools and so forth, and then just look at spatial relationships between the two. It's really just a Spatial Studio hands-on lab to show how you can load, prepare, visualize, analyze spatial data, self-service, without any coding, using Spatial Studio. Now, this one, unlike the previous workshop, this one's not published for public access. However, on Live Labs, if you search for Spatial, there is an introduction to Oracle Spatial Studio hands-on lab, which is pretty similar in terms of the same flow of getting data loaded, prepared, visualized, analyzed. So I'd encourage you to go to Live Labs and check out the Spatial Studio Live Labs there. Then there were a series of demos that we did, and I think these are sort of interesting because it's an opportunity to show both sort of general purpose things and some of the specialized things that we do. And when you're at these events, it's really cool because you can come to our booth, and we'll be doing these demos, and then we can just start to talk and understand what you're trying to do, and then just kind of explore and adapt the things that we're showing to the use cases that folks have. And so that's one of the things that we did that's always a really good part of these kinds of events. So self-service with Spatial Studio was all about sort of an end-to-end flow where you want to really sort of enrich a bunch of locations, enrich a bunch of items with location-based attributes and metrics. And in this case, we had a bunch of customer locations, a bunch of warehouses, a bunch of regions, and we want to tag, in this case, every customer with what's the closest warehouse to that customer, how far away is it, and then aggregate those distances to the nearest warehouse by region. And that's sort of a very generic sort of set of enrichments that would be useful, for example, as you're getting the data prepared for use in a analytics sort of workflow, or maybe determining where the best place to put a new warehouse would be, because there's a set of customers that don't have any warehouse close to them, and how can we centralize one to sort of close that gap. Now, this is really was a very generic demo, but I would encourage you to, just in terms of getting started with Spatial Studio, we have this Get Started page. It's kind of like everything you wanted to know about Spatial Studio from the beginning, the different ways that it can be set up, and the sort of the purpose and the documentation and everything else. So that's really what this guy was all about. And I'd encourage you just to check out the Get Started to see what Spatial Studio is all about. We also demonstrated the integration of Spatial with other, I'll say, like aspects of this converged database environment, in particular, ORDS and APEX. So ORDS is the feature that allows you to create REST APIs out of the database. So just think anything you're doing in the Oracle database, you can wrap with a REST API, make it develop a RESTful interface. And that absolutely 100% goes for Spatial. So what that means is that you can, and what we demonstrated here, and we have a previous Ask Tom session that I have the link to that demonstrated this, so you can see in more detail. But you can do something like take a spatial query that is asking a proximity question. And I think the question here was identifying or searching for tornadoes that were over a certain magnitude strength and within a distance of some location, any location, and turning that into a REST endpoint, basically a location-based service, a location-based API that could then be used for all different sorts of purposes. So ORDS is ideal for that, because all you need to have is the data and the SQL that gives you the result you want. And ORDS basically allows you to very easily turn that into a REST interface, and a REST interface that is completely customizable. So they could return anything from something as simple as just a basic list of which event IDs satisfy criteria, all the way through to having it return the geospatial data itself as GeoJSON, something that a mapping application could consume and stream right onto a map. So the use of Spatial with ORDS, super powerful. And again, we had a session that included that I'd encourage you to check out the replay of. And the other thing that we showed in terms of that integration was using Spatial with APEX. So for anyone that's not familiar with APEX, APEX is a free feature, just comes along with the database, and it allows you to do database-driven web application development, low code with a like a drag and drop GUI. So it allows you to very easily, quickly and easily create a powerful web application driven by the data in your database with very little or no code. And if you are someone that has the facility to do some coding, you can really do some quite extraordinary things with it as well. But you don't have to be a web developer. It's really meant for people that are sort of database practitioners, because it's all about serving database content in rich applications for web and browsers and mobile devices. So in this demo, we focused on showing a couple things that you have access to very easily at any time. And that's, first of all, there is a series of sample applications that showcase different areas of functionality and capability. And one of those demonstration apps is the Sample Maps application, which is this great showcase of all the different sorts of things you can do with the native mapping features of APEX. So APEX consumes our Oracle Spatial content, our Oracle Spatial type natively, Allows you to just have, like you would have other tables and charts and diagrams on the page. Well, you can have maps that are just natively integrated with Spatial, and they'll just work in conjunction with everything else that's on an APEX page. You saw the ITIS road safety portal that was built with APEX, and that's exactly an example of a application of doing this. So we talk about getting, we showed sample maps and all the great stuff, and you use that as a boilerplate, and you can look at it and sort of look behind the curtains at how these examples are set up and use them as a starting point for doing your own things. So we showed that, as well as how to sort of start from absolute scratch with an empty APEX environment and create a basic example with spatial analysis and mapping. This is another one of the examples that is publicly available on Live Labs. So like I showed you before, developer.oracle.com/Live Labs, and you search for Spatial. And one of the things that you'll see is get started with maps and Spatial and APEX. And you can, again, that's publicly available. You can do that at any time. And that's really the demonstration that we showed. It walks through you setting up this sample maps application so that you can then, like, see what it does, see how it works. And then it goes through, again, like I mentioned, starting from scratch, from a blank page, and getting some basic mapping example up and going. So I'd encourage you to check that one out. Another demonstration that we did was demonstration of the tracking server feature of Oracle Spatial. So this is not a new feature. This has been out. This has been out for a couple of releases now, and it is a geofencing. It represents a geofencing capability. What geofencing means is the ability to predefine some areas of interest, regions of interest, and then to be able to monitor how objects, whatever that object is moving in and or out of those regions, important regions of interest. So the regions can be anything from sort of the perimeter of a secure facility. The geofences could be a buffer around a predefined route that is meant to be adhered to. A geofence could be an area around a shopping mall where you want to know if customers are getting, within that area, and you want to know that so that you can send them a coupon and entice them to come in. There's all kinds of scenarios for geofencing. One thing I mentioned here with this feature is that we've named the feature the Spatial's location tracking server, which implies, in a way, to folks, and I've heard this, that it is a server, another tier, another sort of moving part in the architecture, and that's not the case. So the word server in this feature, please don't take that to mean that it's another deployment of some other mid-tier component. It's really just, it is a feature that is completely built on Oracle database sort of componentry. The way that it works is first, you define what these geofence areas are. For example, in the picture on the right, I've defined these 3 areas of interest, whatever those areas might represent. Maybe they represent areas of like sensitive areas surrounding some facility, for example. So you start by defining those areas. And then when this location tracking instance is up and running, the way that it works is that it's monitors and is listening for messages that are sent, that messages that indicate that a specific object is now at a specific location. And those messages keep on coming. As objects are moving around, you're just sending location messages saying, object 1, 2, 3, whether that's a piece of cargo, or whether it's a person with a mobile phone, or whether it's a vehicle with a location device, whatever that object is, location messages are sent saying, this object is at this location. Now this object is at this location. Now this object is at this location. And as those messages are coming in, the location tracking server is monitoring those locations with respect to the geofence areas. And anytime there is a transition into and or out of one of those regions, depending on what you've told the location tracking server to monitor, a message is generated. And this is all done with both spatial and the built-in queuing features of Oracle Database. It has been historically the advanced queuing feature of the database, and it's now evolving to something called transactional event queues. But it's all based on those queues, not some other additional piece in the stack. So an example we see on the right, you see those positions starting on the left and moving sort of southeast and then northeast. Well, throughout those movements, every one of those pins would have a location message that was sent as it was moving along. There would be 5 messages if we were telling the location tracking server that we wanted to monitor every transition. I don't care if it moved out or moved in, I want to know about both. So in that case, there would be 5 messages that would have been sent. There would have been one for the initial movement out of a region. There would have been one message queued up when it entered the next region, exited that region, entered, and then exited the last region. So that's something that we demonstrated, and that is another one of the demonstrations that was done on a previous Ask Tom session. So we've got the link to that session, and I would encourage you to check that out. And if you have any scenario for geofencing, I think this is a really powerful feature, and it turns out really, really easy to use and to work with, as you can see if you check out that demonstration. Now, the one net new 23C feature that was previewed, showed as sort of a preview at CloudWorld, was a brand new SQL function. It will be part of an upcoming 23C release. So 23C, there is a 23 release that is out, but there are going to be dot releases that are going to follow that. And in an upcoming dot release will be this new SQL function that returns an Oracle Spatial geometry, an STO geometry, as something called vector tiles. So what vector tiles are a format for geospatial data that is optimized for streaming to web clients, for very smooth, high-performance web mapping for desktop and for mobile. It's a really big deal, particularly for the sort of the developer community that works with spatial, to be able to have the built-in capability. Traditionally, this has been accomplished with sort of bits in the mid-tier that will get data out of the database, convert it to this highly optimized format for the web, and deliver to clients. But that would be had been a mid-tier sort of workload. The fact that that's now something that we can do in the database means that capability can be sort of wrapped and exposed uniformly for all the different sorts of clients that work with spatial and deliver that data into browser-based applications. So all of the mapping clients out there, all the popular JavaScript web mapping clients, all support and work with vector tiles. It's ubiquitous, as we do in our own Spatial Studio tool, as does other groups within Oracle that do integrated mapping. I mentioned before about how there's also this thing called ORDS, Oracle REST Data Services, that let you take anything you're doing in the database and expose it as a REST endpoint. Well, this is a perfect case in point. Since this is a SQL function, what we demonstrated at CloudWorld was that it then becomes very easy to take that SQL function and wrap it as a REST endpoint with ORDS, with Oracle REST Data Services. And that REST endpoint that we developed, there is a standard signature, a standard sort of format for how these vector tiles are expected to be exposed. All of the popular mapping clients all will expect and adhere to this standard URI sort of format for vector tiles. And using ORDS and this SQL function, it becomes almost trivially easy to formulate and create such an endpoint, which means that your spatial data can very easily be delivered out of Spatial as vector tiles, ready to be consumed by any modern popular WebGL map client. One of a couple really important things about vector tiles, I mentioned it's optimized, it's compressed, it's very flexible in that vector tiles represent the data, the content, and the styling of the data, unlike so-called image tiles, where you'll see a web map and the map content pops into the screen as these little image squares all over the screen. Those sorts of maps are styled in the backend on the server. So every different map style you want would require a whole separate set of those tiles, because the tiles themselves are styled with different colors and so forth. Well, vector tiles are just the data, and the styling is done using style sheets, and done by referencing different style sheets, or even in the client. And that's really important because it means you have one set of vector tile data that's compressed, optimized for all clients, and it's only loosely coupled or sort of decoupled from the styling. So you can have one set of this vector tile data, and from it create all different sort of map styles: light, bright, dark, institutionally sort of customized to branding colors and all that sort of stuff, all from one common set of data. So it's a really big deal, and you'll be definitely hearing more from us about this. And then the last item was the one I had that gold star for, because it was, really was the hit of the show. And it was a demonstration of how all this Oracle Spatial 3D stuff that I talked about, with point clouds and point cloud difference and so forth, digital twin, how all that can be brought to something that's just really cool, exciting, fun. And Paul Parkinson from the database team created this and had with him a scanner that would let people do. He would scan people. That scan would be turned into a 3D point cloud and stored in Spatial, and then would let them do a 3D printout of themselves. And it was pretty crazy, and there were long lines, and it was really, really cool. And that was the first thing, basically creating a digital twin, a 3D print, to have a little model of yourself. The other really interesting thing that he did was to show this change detection or difference detection using Spatial 3D and 3D mesh. And the scenario was to do a 3D scan of your hand, and then put a ring on and do a 3D scan of your hand, and then see how the change detection capability of the associated point clouds and 3D mesh allowed you to do the delta, which is literally that ring that was put on your finger. So the things that I talked about earlier in terms of sort of the technical aspects of the new 3D stuff in 23C, well, Paul Parkinson kind of brought that to a really, again, intuitive, fun level, to what was, I think probably the most buzz around the different booths we had in our area at CloudWorld. Now, there's two links I have here. One of them is a kind of a preview where Paul is interviewed and talks about what he was doing here with this, and then the other one is kind of a technical walkthrough of how all this works, sort of demonstrating it. So I really encourage you to check out these YouTube videos of this, because it was really, really cool. So that's sort of the overview, and hopefully that gives you a feel for the kind of stuff that we do at these events and why it's hopefully encourage you to come. We have an upcoming event in April, the Analytics and Data Summit, that is hosted or put on by the Oracle user community. So that's coming up, and there's the link here for more information. I'd encourage folks to look at that, because our team is part of it. And I'd also encourage you to save the date for the next one of our Spatial Office Hour sessions coming up on the 28th. And Karen, I think I'm probably just about out of time, and I don't know if there's any questions that haven't been answered, but I'll turn it back to you now.
Okay, thanks a lot, David. Everything you talked about sounds very exciting. So, and hopefully people have the chance to follow up on at least some of the things you presented, links you provided. So yeah, I also want to encourage you to look at the things you are specifically interested in. And if there are any things you need further explanation on, just drop us a note. Our email addresses are first name dot last name at oracle.com, so david.lab@oracle.com, or the same applies for me and my colleagues who are with us, like Giant or Denise. Don't be shy, just reach out to us. That's why we are here. We had a couple of questions in the Q&A, so we tried to answer all of them. Amin, I just wanted to let you know that if you remind me via email regarding your question, I can.
If we still have like 1 minute, I'm just looking at it now. How do you get the message from the target object? So I assume that was about location tracking.
Yeah, I assume
So
so.
the way that works is that it does use Oracle queues, these just the built-in queuing feature. So when you're sending you send a location message via a function call. So it's like a PL SQL execute a function call that sends a message to the location tracking server. And when the location tracking server detects entry or exit from a region, it puts a message in the event queue. And those event queues, this at this point has nothing to do with spatial. It's all about message queues. So you can subscribe to message queues. You can look at the queue to see if there's a message on the queue. You can dequeue the message. There's a whole way and operational sort of framework around working with event queues. And this is one of the benefits of Spatial being part of this converged database. We didn't have to invent a whole queuing framework for this. We're just using the existing Oracle event queuing framework. So that's sort of the answer is that you would either monitor the queue or you would subscribe to, and sort of which there are ways to do that as well, sort of subscribe to the queue to be notified. And like Karen mentioned, we'll be glad to get into more detail with you if you ping us.
Yeah, I have an example already, some sample code which goes through all the steps, so you can just grab it, adapt it to your own data, and let it run. So that's why I mentioned to reach out to me, remind me, and then I can share the sample code with you. Okay, then there was a question, Martine. So the email is David, can you please switch to the next slide? I think my email address is published on the last slide.
I don't have your last slide, but I can put it up here.
Okay.
Well, why don't you just put it in the chat or some, Karen, and we'll see it.
Yeah, I can just let me type that in so it isn't that hard. Here we go. Okay. I think everything you asked has been answered. Jane, you took care for Martine's question.
Yeah. So David, the question was, will the vector tiles work with the APEX map region? And
yep. And you're right. I took a look at, and you had said that is like a roadmap item. So yep. And that will come, and we're already working with them.
Okay. So the topic for the next session is not yet fixed. So there was the question to have a specific session about 23C features, but we also have other things on our list. We will figure this out soon and let you know about the next session. We will definitely have a 23C spatial features session, but I won't promise it to do it the next time, but I've added it to our list.